The polynomial p is given by this equation here. Find the remainder when p is divided by x plus 1. Use the factor theorem to show that x minus 3 is a factor of p. Express p in the form of this, where b and c are integers. Hence, show that the equation here has only one real root, and state the value of this root. So here's the question here then. Let's have a look at it. Find the remainder when px is divided by x plus 1. So part 1 then. Let's have a look at that. So remainder, and it's divided by x plus 1 will be p of minus 1 is equal to, put minus 1 into the polynomial, minus 1 cubed minus 4 times minus 1 squared, plus 4 times minus 1, put that in there, minus the 3. What do we get? We get 1 with a minus, because it's minus cubed. We get, this is just plus 1, this is minus 4 then. This is another minus 4, and this is minus 3 at the end, isn't it? Minus 4, minus 3. So they're all minuses. So we get minus 5, minus 9, minus 12. So there's the remainder. So that's that one done. Part 2, use the factor theorem to show that x minus 3 is a factor of p. So part 2, we need to work out f of 3, don't we? And show it, p of 3 rather, and show it equals 0. Naught cubed, p of 3, so it's 3 cubed, minus 4 times the 3 squared, plus the 4 times the 3, minus 3. 27. 27 minus 36. 27 minus 36. 4 9s are 36 with a minus, plus 12 minus 3. Plus 12 minus 3 equals minus 9, and this is 9, so equals 0, which is what we wanted. So x minus 3 then, this value is a factor of the polynomial p. So that's part 2. Express p in the form of this, where b and c are integers. So we'll need to divide x minus 3 into this cubic here. So let's do that then, shall we? Straight away. Part 3. So here we want to divide x minus 3 into that cubic x cubed. Let's just remind ourselves what it was. It's minus 4x squared plus 4x minus 3. Minus 4x squared plus 4x minus 3. So how many times does x go into x cubed? It goes in x squared number of times. Multiply through. X cubed minus 3x squared. Take them away. This take that will cancel. That's why we're doing it. This take away minus is plus, so we get minus x squared. Bring down these terms that still remain. So how many times does x now go into the x squared? Is minus x, isn't it? And now multiply through minus x squared plus 3x and take them away again. So this take that will cancel. This take away 4 take 3 is just an x, and then we're still left with a minus 3 take nothing, which is minus 3. How many times does this go into this? It's just going to be once, isn't it? Plus 1. One lot of x minus 3 then. 1x and one lot of minus 3 is there. Take them away, we get 0. So this times this will equal this. So this is part 2, part 3, isn't it? So the cubic, x cubed minus the 4x squared plus the 4x minus 3. The p of x, in other words, is equal to x minus 3 times by x squared minus x plus 1. So the b was minus 1, which is minus 1 lot of x, and c is equal to 1. So that's that done. B and c are integers, which is fine. Let's go back up then to check where we are with the question. So b and c are integers, which we've done. Hence show that this equation, which is none other than this quadratic, has only one real root, and state its value. So this is part C. Since p of x equals naught has only one real root at x equals 3. So this equals naught when this is naught. And that's because this quadratic b squared minus 4ac, let's work that out and see if we get, is equal to minus 1 squared, which is 1, minus 4 times a, which is 1, times c, which is 1, which equals minus 3, which is less than 0. So no roots for quadratic. So we needed to say that, of course, didn't we? We could have said that prior to saying this. So there's the only real root that follows from this problem, x equals 3. And that completes all parts of that question, 5b and c.